Okay, class, let's solve these three exponential equations. I've got 2 to the power of 4x plus 1 equals 64. What I notice is that on the right-hand side, I can set the bases equal because I know that 2 can be raised to the power of 6 to give me 64. Okay, so now the bases are set equal, and we've got what is called the one-to-one property of exponential functions. It says that if the bases are equal, okay, the bases are equal, that gives us these two range values that are equal, and that will then mean that the domain elements are equal. Okay? Those exponents are going to be equal. So now that gives me a simple linear equation, 4x plus 1 equals 6, and I can subtract 1 from both sides and then divide by 4. So x is 5/4. Okay, and you can check it. If I plug in 5/4 in here, the 4 here will cancel with that 4, and that'll leave me with a 5. And then it'll give me 5 plus 1 is 6. 2 to the 6th power is 64. Okay. Now, the next example, our exponential function needs to be isolated because we're subtracting 1 from it. And there's no way that I can combine these two terms together. So we'll simply add 1 to both sides. And now I have a similar equation to this one over here. But I'm not going to be able to take 3 to a nice rational power to give me 17. This number turns out to be an irrational number, and I don't know what it is off the top of my head. Okay? So what we're going to do is we're going to simply change forms. I'm going to rewrite this in logarithmic form. Okay? The 3 here is the base of the exponential, so now it will become the base of my log. And this 17 is the output for the exponential function, and now it's going to be the input for the log. Okay? So when you have a log function, this in the parentheses, the expression in the parentheses is what the function is acting on. Okay? So this becomes its domain element or input. Okay? But now that logarithm has to equal x plus 2. Because remember that a log function is always producing outputs, which are exponents. And previously, this entire exponent was acting as an input. Okay. So now the entire x plus 2 is acting as an output for that log. And then we're going to subtract 2 from both sides. And this is our solution, okay, in its exact form, okay? But if we wanted to provide a decimal approximation, we're going to have to use the change of base formula, okay? My calculator doesn't give me base 3s, so now I'm going to have to rewrite it using the change of base formula so that we can get a decimal approximation. Okay. And so our answer is roughly 0.5789. Okay? So that makes sense, because look, if you have this is a value that is roughly, it's close to 0.6, right? So if I took 0.6 and add it with 2, you'd have 3 to the power of 2.6. And that's going to then give you something very close to 17. Okay? But we know that 3 to the second power is 9, and we know that 3 to the third power is 27. So we know that this whole exponent has to be between 2 and 3. Okay? And with that x value, it would then give us an exponent between 2 and 3. Okay? Now the last example, we again have to isolate this exponential function because we're being multiplied with 2. The order of operations would not allow me to perform that multiplication before the exponents. Okay, so we're going to divide it out. And now that gives me e to the 2x equals 4. And I'm going to again change forms. So I've got log base e, right, because the e is the base, and in a moment I'll just put ln. Okay, and then now that 4 is going to act as the input for the log, and then the exponent is 2x. Okay, the logarithmic functions always spit out outputs that are equal to the exponent. Okay, and so now we've got 2x is equal to the natural log of 4, and then divide both sides by 2, and x is equal to the natural log of 4 divided by 2. Okay, and we can get a decimal approximation for that. Okay? This is the exact solution to our equation. And so x, as a decimal approximation, is roughly 0.6931. Okay? And so we can then check our answer by taking that decimal, plugging it in here for x, okay, multiplying by 2, and then raising e to that power, multiplying by 2, and that should give us something close to 8. All right? Hope that helps.